Hello, everyone. Welcome to my channel. This is an educational channel focused on the esoteric and obscure things that I think are very important for people to know, to learn about. And today is, I think, the 182nd video on the reciprocal system of theory. And this is a theory of everything, or a system of theory that was devised by Dewey B. Larson back in the 20th century up until his death in 1990. The general idea is that Larson's universe is a universe of motion, not a universe of matter, not a universe of energy, but a universe of motion. And motion is the relationship between space and time, which sets up a generalized reciprocal relationship between space and time. Space and time don't actually exist, they only exist together in motion. An easy example is speed. Speed, the car is going 10 miles per hour, 10 miles of space in 1 hour of time. You double the speed and you're going 20 miles an hour, 20 miles of space in 1 hour of time. Or you could also say you're going 10 miles in half an hour. So that shows you that there is a reciprocal relationship in speed between space and time. But speed is not the only relationship between space and time. All motions, which are really all scientific quantities, are relationships between space and time. But it is a bit more complicated because space and time have their coordinate aspects, meaning that they are three or more dimensions. X, Y, Z coordinates of space, we are familiar with that. X, Y, Z, but also time has its coordinate aspects. So time has three or more dimensions as well. In addition to that, time and space both have their scalar or clock aspects, meaning that they possess a kind of motion that has a magnitude but has no particular direction. Just like if you put a bunch of dots on a balloon and you blew up the balloon, all the dots are moving away from each other but in no particular direction. This is what Larson calls clock time. The clock is always getting later and later and later, but in no particular direction. And clock space. Everything in the universe is getting farther and farther and farther apart, but in no particular direction. And this motion at the speed of light is what Larson calls the progression of the natural reference system. This is basically the ether, or the origin, or the midpoint of this universe. And you can see that in what Larson calls the discrete unit postulate. There is a minimum unit of space and a minimum unit of time. And if you have exactly one unit of space in 1 unit of time, you have the speed of light. So the speed of light is 1. And then everything above 1 is half the universe, called the cosmic sector, and everything below 1 is the material sector, the other half of the universe. The material sector is really the only sector that the legacy scientists know anything about. The cosmic sector is, this is shown by Einstein's dicta that said that the speed of light is the maximum speed of the universe. In the cosmic sector, the speed of light is actually the minimum speed of the universe. Everything in that universe is moving faster than the speed of light. We don't exactly have a firm grasp of that, but since we understand the material sector, we can extrapolate because what's going on in the cosmic sector is exactly what's going on in the material sector, except that the roles of space and time are reversed. So, in the material sector, we have primarily relationships that are in space. Um, and in the cosmic sector, they're primarily in. Well, we won't say that because space and time are not really the container of the universe. They are really the contents of the universe. And you can abstract. You can take an abstract picture, snapshot uh, of a part of the universe and say that something is in space or in time. But really, space and time represent the contents of the universe. Now, what Larson basically did is he developed this universe step by step through induction until he was ready to understand the basic principles, and then he put out his fundamental postulates. Two very short postulates. One of them is basically the universe is made out of motion, and motion is the relationship between space and time. Space and time have their coordinate aspects, and they have their scalar aspects, and they come in discrete units. And the other postulate is the universe adheres to the basic quantities of absolute mathematics. Its magnitudes are absolute, and its geometry is Euclidean. That's just a paraphrase of it. But so then, once he had those postulates, then he went on a process of deduction. If this, then that. And he derived an entire theoretical universe of what his universe would look like in theory. And then eventually he compared that universe to the actual universe that the scientists had been measuring, exploring, and measuring and quantifying. And, he basically identified different things within his universe with things within the legacy scientists universe. And mostly 90% of the things that the scientists had discovered fit in seamlessly in his system, and then the 10% that didn't were generally on the margins of the very fast, the very small, the very large, and I guess the very slow, just the relativistic stuff. And so he basically provides an alternative to the relativistic stuff. And that's why he's got a book that's called Beyond Newton. His launching point basically, the Newtonian universe basically fits in to Larson's system, but the Einsteinian universe does not. That's a simplification, but it's a basic idea. Okay, now we're looking at his 1979 book called Nothing But Motion, and we're in chapter 11 of this book that's called Subatomic Particles. And we're taking over right in the middle of the chapter. He's discussing. He was discussing the the proton, and the neutrino, and we'll let him go from here. In the previous publications, the M 1/2-1/2-0 combination was identified as the neutron, but it was noted that in some physical processes, such as cosmic ray decay, the magnetic displacement that could be expected to be ejected in the form of neutrons is actually transferred in massless form. Since the observed neutron is a particle of unit atomic weight, it was at that time concluded that in these particular instances, the neutrons act as combinations of neutrinos and positrons, both massless particles. On this basis, the neutron plays a dual role, massless under some conditions, but possessing unit mass under other circumstances. Further investigations, centering mainly on the secondary mass of these subatomic particles, which will be discussed in Chapter 13, has now disclosed that the observed neutron is not the single effective magnetic rotation with displacements m 1/2, 1/2, 1/2 - 0, but a more complex particle of the same net displacement, and that the single magnetic displacement is massless. It is no longer necessary to conclude that the same particle acts in two different ways. Instead, there are two different particles. So he's basically making a distinction between his massless neutron, 1/2 - 1/2 - 0, and the compound, what he calls the compound neutron, which I guess he'll be introducing later. The explanation is that the new findings have revealed the existence of a type of structure intermediate between the single rotating systems of the massless particles and the complete doubled systems of the atoms. In these intermediate structures, there are two rotating systems, as in the atoms of the elements, but only one of these systems has a net effective displacement. The rotation in this system is that of the proton, m1-1-1. In the second system, there is a neutrino type rotation. The massless rotations of the second system can be either those of the material neutrino, m1/2-1/2 - 1, or those of the cosmic neutrino, which is on a cosmic rotational base, 1/2, 1/2 - 1. I don't quite get that. I would think that that would be -1. But be that as it may, with the material neutrino rotation, the combined displacements are m 1/2 - 1/2 -2. This combination is the mass 1 isotope of hydrogen, a structure identical with that of the normal mass 2 atom, which is deuterium, m2-2 -2, or m2-1 -1. In the atomic notation, except that it has one less unit of magnetic rotation and therefore one less unit of mass. When the cosmic neutrino rotation is added to the proton, the combined displacements are 2m 2-2 -0. Now remember, when you put the M or the C in front of these, that is indicating a subatomic particle and using the subatomic particle notation, which is different than the atomic notation, because it's counting more of the rotations. The same net total as that of the single magnetic rotation. So M2-2 -0, he says the same net total as that of the single magnetic rotation. This theoretical particle, the compound neutron, as we will call it, can be identified as the observed neutron. He's gotten pretty far into the weeds here with this notation and this system. but we will continue. The identification of the separate rotations of these intermediate type structures with the rotations of the neutrinos and protons should not be interpreted as meaning that neutrinos and protons actually exist as such in the combination structures. What is meant is that one of the component rotations that constitutes the compound neutron, for instance, is the same kind of a rotation as that which constitutes a proton when it exists separately. Inasmuch as the net total displacement of the compound neutron is identical with that of the massless neutron, those aspects of the behavior of the particles, properties as they are called, which are dependent on the net total displacement are the same for both. Likewise, those properties that are dependent on total magnetic displacement or total electric displacement are identical. But there are other properties that are related to those features of the particle structure in which the two neutrons differ. The compound neutron has an effective unit of three-dimensional displacement in the rotating system with the proton type rotation, and it therefore has 1 unit of mass. The massless neutron, on the other hand, has no effective three-dimensional displacement and therefore no mass. The two neutrons also differ in that, although it is a still unobserved particle, the massless neutron is theoretically stable in the material environment, whereas the life of the compound neutron is short because of the foreign nature of the rotation in the second system. After about 15 minutes on the average, the compound neutron ejects the second rotating system in the form of a cosmic neutrino, and the particle reverts to proton status. And so that makes you very much question, as the legacy scientists have not done, how the neutron can be one of the building blocks of an atom if it's only stable for 15 minutes and it decays into a proton. But that's one of only a number of anomalies within the structure of the nuclear atom. Okay, and Larson gets around that because he says that there is no nucleus of an atom. An atom is just one thing, and it's a combination of different kinds of motions, but it's one motion, one thing, just like a curveball, which is also a combination of motions, but it's one thing. The structures of the subatomic particles of the material system may now be summarized as follows. Okay, so the massless particles include the 0-0-0 rotational base. This is all on the material. I don't know what the term there would be. The material. I guess that would be the material rotational base. And so 0-0-0 is the rotational base. And then M 0-0-1 is the positron. M 0-0-1 is the electron. M 1/2-1/2-0 is the massless neutron. And M 1/2-1/2-1 is the neutrino. With particles with mass, we have M plus, which means charged, even though he hasn't gone over that at all yet. 0-0-1 is the charged positron. So it's the same notation as the positron, but it's M plus instead of just M. M minus, the charged electron, is 0-0-1 on an M minus rotational base, the charged electron. Then we have the proton, M1-1-1, and then we have the charged proton, M plus 1-1-1. And then we have the compound neutron, which is one on a material rotational base and one on a cosmic rotational base. The compound so on M we have 1-1-1, and on C we have -1/2, -1/2, 1. And those two combined together, it adds up to 1/2-1/2-0, the same as the massless neutron, but it's using both of those rotational bases, so it's a compound neutron. All right, well, that is the end of that chapter, and don't get discouraged if you're not following along. I'm struggling mightily here to follow along with these different kinds of notations and kind of the derivations, but just hear him out. That's the general idea. You hear him out, let him say what he has to say, and then you can let it percolate in your head for a while, and take what you need and discard the rest. And so we will be going into chapter 12 tomorrow, Basic Mathematical Relations. Until then, have a great day. Thanks for tuning in.